Hi, everybody. In this video, I'm going to go over parallel versus perpendicular. Also talk about what that word skew means that you might have seen. I also want to talk about parallel and perpendicular as it relates to segments and lines versus planes. So when I'm talking about parallel or perpendicular segments or lines, a lot of times, especially when we're talking about perpendicular segments, those need to be in the same plane. So for example, UV as a segment is perpendicular in this diagram. Oh gosh, that looks horrible. Is perpendicular to UQ. Those are in the same plane, right? They're in plane UVR or QUV, however you want to look at it, and they form that 90-degree angle. Line UV, or segment, excuse me, segment UV is not perpendicular to segment WS. Forgot to put the little bars above my segments. Um, those are not perpendicular because those are not in the same plane. So they're not even intersecting, right? How can they be intersecting to form a 90-degree angle? So these are what we call skew lines or skew segments in this case. Planes are perpendicular when they touch to form that 90-degree angle. They intersect to meet that make that 90-degree angle, and they're parallel when they never ever intersect, when they're equidistant from one another. Same is true for parallel segments. Okay, I'm gonna clear these drawings. The diagram below is a right rectangular prism. That means all the angles shown measure 90 degrees, hence the right. And then the rectangular prism means all of the faces on the sides of the shape. Well, sorry, not the faces. The bases are rectangles, and then a prism, all the faces should be rectangles. So I hope I'm recording. I don't know why I'm doubting it. Okay, good. We want to find two planes that are perpendicular, meaning they intersect to form that 90-degree angle. I should see something that looks like this. 90-degree angle. Otherwise known as a right angle. And I can pick any plane. Pick a plane, any plane, and we should be able to find one that's perpendicular to it. So I'm just going to pick the top, which is UVW or plane XWV, however you want to name it, as long as it is a combination, three of the four letters. So this is plane, I'm going to call it UXW. And to find one that is perpendicular to it, I want to find one that meets at a 90-degree angle. And thinking about how a rectangular prism works or a box works, if we have the top and all of the sides are meeting it at a 90-degree angle, I can pick any one of these sides, and that plane is perpendicular. So I'm going to switch colors. I'm going to choose this sidewall here, which would be VWR or VWS, WVS. Again, pick three of the four letters to name this plane here. So that is plane, I'm going to call it RSW. So plane UXW is perpendicular to RSW. If I wanted to find a plane that was parallel to UXW, the plane that is parallel to UXW would be this QRS, plane QRS, the bottom. That's not what the question is asking us. The question is asking us perpendicular. So UXW, and make sure they're all capital, and RSW. All right. Look at this one. The diagram below is a right rectangular prism. All the angles all the angles shown measure 90 degrees. Name two segments drawn in the diagram below that are parallel. And so for this problem, I want my segments to be in the same plane, because if they're not in the same plane, I mean, of course, they're not going to intersect, right? So I always like to pick the top of my box. Maybe this time I'm going to pick this side here. So PMI or LPM, however I want to name it. So this is the side I'm going to look at. This is our plane. PML, and you might be like, well, they're not asking us about a plane. And I know, but they're asking us about parallel segments. And again, I would like them to be in the same plane. So I'm going to pick a segment within this plane. So here's plane PML. Here's my rough sketch of it. Here's M, here's P, here's L, and here's I. If I want to find parallel segments, I hope y'all know that this is really just a rectangle, right? It's a slanted rectangle. We're viewing it as an angle. So this side should be parallel to the opposite side opposite it. So MP should be parallel to IL, and IM should be parallel to LP. Opposite sides are parallel in a rectangle or in a square or in a parallelogram. However you want to look at this shape, I should be able to find some parallel sides. So we already kind of listed them. Maybe I'm going to do segment MP and segment IL or LI, however I want to name it. MP and IL. And it's going to automatically do the segments because it's telling us to find segments. And notice it's saying, hey, these are both in the same plane. So we have found planes that are lines that are not in the same plane. Let's see what happens if we want. Oh, this problem's asking for skew. This would be a good one to do, actually. The diagram below is a right rectangular prism. All the angles shown measure 90 degrees. Name two segments drawn in the diagram below that are skew. This will be my last problem. So skew means they are not in the same plane. And they don't really look like they're parallel, necessarily, but they're not in the same plane. So I am going to pick a segment, any segment. I'm gonna pick this segment CF down here. So just a side on one of the sides of my right rectangular prism. So CF is a segment, and a segment that would be skewed to this would be a segment that's never ever going to intersect it, kind of go in an opposite direction, just doesn't really look related at all. Maybe JI. JI certainly is never going to come in contact with CF. They're in two totally different worlds. Maybe HD. That's even skew yet from JI. All three of these are skew from each other. So I'm going to pick CF and JI. As long as they're in different planes, that is really the key. They're neither parallel, nor do they intersect. So please, y'all, let me know what questions you have on these sections. I know this is kind of tricky stuff when you're working with this vocab, but practice makes perfect, and I'm here to help every step along the way.